Alright, before we get started, I just want to show you, this thing here is pretty cool. We got all kind of different chemistry going on here, but it's all one piece. You see this? You see all that? That's one piece, and then in the front it's all this green and all this business going on. And this is just glued on there, but the one in the back is not. You see that one there? That's not glued on there. That's just growing as part of that crystal. And then it's just got, it's obviously it's a little sculpture thing. And we got a little yellow crystal there. The green. We're going to take a look at all this in a microscope. And then I believe these are mica panes. They could be selenite. And then look at this. Check this out. You see that? Whoops, you can't see that, can you? You see this? What caused that? What created this, do you think? You see it? I know it created it. This is cool. I love this stuff. Once you understand the chemistry, and like this here, you see that? That's a lung. That's a lung. Now I'm going to show you the microscope, and I'm going to show you what. These are called vugs, these little holes. You see them? They're all over the place. Those are vugs. Crystals grow in vugs, and this has some in it. We're going to look at it in a microscope. Okay, my friends, this is going to be fun. I get a lot of questions about crystals, and where do they come from? What's all these different colors? Well, the colors, we're going to go through how the colors get incorporated into the crystals. But first of all, why do crystals form? I mean, why are these shaped the way they're shaped? And I'm going to go through all of this, and we're going to go through, we have the microscope going, we're going to have a good time. But I can tell you right away, it's all chemistry. You see that? It depends on the different types of chemistries where the center of polarity is. It's as simple as that. And then because of the way certain chemistry works, silicon dioxide primarily, which is quartz, it takes on this particular crystal shape. And then it attaches to some of these transition metals depending upon the seed. And we're going to talk about the seed uno momento. See, everybody thinks of quartz is just a clear crystal quartz, and they do. They make absolutely fabulous looking things. But that is in an area where there is nothing but silicon dioxide to fill these things. See these here popular quartz gems? The rose quartz, amethyst quartz, all different types of quartz. And what are these? Those are transition metals, and the transition metals, are these right in here, and they bond to the silicon dioxides as they're moving to fill in the holes. That's what this is all about. All right, before we go too far here, we all know crystals are quartz crystals and amethyst and all these different types of colored quartz-based crystals, but they're silicon. You see up here is carbon? It's right above it on the periodic chart. And the reason it makes diamonds is because both of them have 4 additional electrons in their orbitals. Now, when I say electrons, everybody knows that I'm fighting like crazy against the atomic model. Subatomic model. Not once you get into these. I'm fine with this. This works perfect. But once you go below the nucleus, then you're in trouble. So that's where my issue lies, is that the nucleus is not made of a gigantic positive. Just so you understand where I lie, this is the nucleus of all atoms, a bazillion little electrons. It's not like that. It's not like that. Not one big gigantic chunk. Protons are not like this. They're 1,839 little electrons. That gives us the ability to do so much more than they have ever expected. Because we can break up, and they know this, because they know that they can take one of these and take a couple of electrons out, or 1 or 2, and they make it into an isotope. It's called a charged particle. How did that happen? How did that happen? Then they have, like, a proton is one size, and then just one extra one of these, and they know it's the size of an electron. Turns it into a neutron, because now it has an equal number of everything. So that's my issue with chemistry right at the moment, is the subatomic nuclear part. Here, totally different situation. So here we have silicon, we have carbon. Silicon makes crystals, yep. Carbon makes crystals, yep. Carbon makes a lattice of only itself. All right, carbon, 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 all by itself. Silicon adds together with silicon dioxide, 2 oxygen molecules, which gives you that 4 extra particles. This one gets, it just attaches to another carbon to make its own diamonds. So that's the difference, and they're hard. They're much harder because they're just nothing but carbon. Silicon has a little bit of adjustments here and there with the oxygens, so it can fall apart a little easier. It's not quite as hard as the carbon. Okay, so what are we talking about when we talk about crystal seeds? A seed crystal is a small crystal that is used as the base to grow a large single crystal. And then they grow really nice if it's good, if it's a good seed. You know, a good seed grows a good crop. Without a seed, crystals just form slowly and randomly, and they just, you know, and I'll show you some that don't have good seeds and they didn't grow well. But I'll show you some that did have good seeds and grew very well. When the seed is placed in a saturated or supersaturated solution, it acts as a nucleation site. And then, as I showed you, these, if you have the right starting one, they have to line up together. There's no option. They have to, because they will only accept a certain set of molecules attaching in a perfectly lattice relationship. And that's how you get these crystals with these points and everything. That's all natural. All right, so I'm sure I showed you this was a lung, but if I didn't, that's a lung. Now, we're going to look at this in a microscope. This is the microscope up here. It's a telescoping one, so we stand way off, and then we can drill down in and so forth. And we're going to see a non-nucleated crystal formation, which means it's just randomly filling in vugs. And when they say veins of quartz, that's all it is. They're filling in holes. Quartz is a hole filler. And if you start with a good crystal, you get a good seed. A good seed crystal, you get a good crystal. If you start with just little spots here and there, like this here, you don't have any good seeds here. They're just they're just randomly here. But that one there started its own good seed, basically. You know, think of it in that way. And you'll see it in here in a second. We have to turn the lights off, so hold on. Okay, my friends, that is the lung. That is the lung, and you can see all the red blood. We're going to look at it again real close. But that is the vug. Let me see if I can home in a little better. That's the vug, which is one of the holes in the lung, which would have been an alveoli, and now it's filled in, or starting to fill in with crystal. But this is one of those just random looking crystals. Hold on a second, I think I have other shots. Okay, now this is right up close, and you can see that the crystal quartz is just starting to fill in. Now, if you start with a perfectly good seed, you get a perfectly good crystal. Once it starts, if it's perfect when it starts, it has no other way to form other than to continue on with that. Now, if it has metal attachments, which are these metal attachments down here, all right, if they're in there, then you have the same sort of thing. You get a colored crystal, like this right here. You see this one? This little headdress crystal here. Hold on. I don't know, I think that's not going to be... All right, well, I guess you can see that. You know what crystals look like, amethyst and all the different colored crystals, and those are these colors up back here. All right, now, the other stuff is also biological, and it's nucleophilically substituted. That's what it's called. And all of these little lines and all that, that is all biology. I know it sounds crazy, but it's true. And this right here, I told you about that. That right there is a tendon ball. And they cut it right across. Hold on, let me see if I can get a better shot of this. You see the two holes there? Those are the blood vessels coming out. Right out of there. All right? And that's the type of core this had in the center. Let's see if we can get it a little better on a microscope. We might be able to see the actual blood inside that fed this. Because everything has to be fed with blood, but that was a tendon ball. See it? All right, now let's, and then we take a look at all of that stuff in the back and all the crystals and that crystal there and some of this stuff on here. I mean, this is kind of fun for me. I enjoy this a lot. Because there's so much to investigate, because it's all new now. A lot of this stuff, nobody really ever, well, nobody considered it to be biological. That's 100% certain. But now the diversity and the sizes and how these things formed and where they formed, and I mean, it's a never-ending puzzle. But the pieces fit together very easily. We just got to look around for the puzzle pieces and then put them together. And it's not hard to do at all. So we're going to do it together. If you like puzzles, you are in the right place, my friend. Okay, here's that little lung again. This is literally blood. That is blood. These are probably like blood cells. And then they sort of congeal and they glob together. And that may even become a little crystal. But they take over and then they start to grow, because they just grow. I can't really say exactly why, but they do grow. Because they want to adhere to something of their own species, which is the silicon dioxide. And sometimes, because this is all blood, that's all blood, and that really contains virtually all the transition metals. Because blood is nothing but transition metals, almost. Now, because those are the things that carry everything through your body. You see this here? All of those different attachments, those are different abilities to grab. They pinch. They call them ligands. And they pinch and they drag it down to where somebody else wants it, and they give it up, and it drops them. It's nucleophilic, and it's in substitution. They bring something down and they substitute it and bring something else back. That's all. It's the same thing as when they die. I say it's all nucleophilic substitution that causes the preservation. It's because now it comes down and it attaches and it just stays there. But this time it's not picking up the garbage, it's coming in and it's locking in these aqueous solutions. And you have a lot of salts, you have a lot of chemistry, and then everybody will find somebody they can stabilize with if they're in that type of chemistry long enough. So everybody did, and then when it dried up, they all turned to stones. Once you lose all the water, they dehydrate, it's called. All right, this is in the microscope on the back of that little statue thing that I had here. Now, this is some kind of metallic deposit. I don't have a chemistry lab here. I don't know exactly what it is, but it is a chemistry deposit. And you can see them, they like layer in flat little plates. And this one started off with a good seed, well, pretty good, and it pretty much layered and layered and layered and layered into this cube. Some cubes are absolutely 100% flawless. Now, this had all kinds of other chemistry, so nothing here is flawless to speak of at all. Look at that. I'm moving my hand over the light and it's refracting differently. Now, the other beauty about this little microscope is you can adjust the light down to where you can almost, like, what these are, I don't know. Whether they're angled just the right way, more than likely. But sometimes you can actually discriminate between chemistry, the different colors, as you bring up the brightness. But anyway, let's take another couple of quick shots at this, and then we'll do something else. All right, remember I showed you that spot that came up the side of that plate, and I said it was a tendon ball? That's the artery, and that's the vein, I believe. Now, this is extremely dry right now. I'm going to put a little moisture on it. It should bring out the coloration. And again, I tell you, I can tell the colors. I can tell what it is by the colors. And we'll take a look. Maybe I'm going to put a little moisture on it. We'll come back in a second. Alright, that looks pretty red to me, and that little stub is, I believe, the actual spot. Now, you see all these little divots here, these little dots? That's what's on a tendon ball. They have all those little anchor spots in it so that it'll stick in your body. And there's the vein, the black one. See the black one and the red? They come together to feed you with red blood and to bring back the bad stuff. Now, looks like it to me. Alright, if you look carefully, you can see the two dots up there, which are basically the blood vessel tips. You see the little white spots running up to them? And then they feed all of this stuff down here. Now the center is a whole different issue. That is where the structural part of this is. And I have them like this all over the place. You see the top? That's the places where I was showing you, only of course they end up right at the very edge because they have to come out. Otherwise you've got a no flow. Alright, this is a very interesting shot. Again, specific gravity makes things accumulate in certain ways. If I had to make a guess, I would say this is gold. I would say this down here, these shiny little platy looking ones are well, hold on, let's get a little closer in there. I would say those are pyrite. You see as we come down onto them, they're like platy, shiny. This is not, and I believe this is gold, and I believe this is probably pyrite down here as it goes down in a different area, because different minerals will collect in different loads, and sometimes you get the mother lode. Okay, the wings, I'm going with selenite. I have selenite right here. This is the same thing I have right here, selenite. You see it? And this still has some of the actual blood in it. Now, let's go a little further. Alright, here's that little crystal. It's at the top. And this looks heavily included, which means a bunch of junk inside the crystal is not supposed to be there. Perfectly clear crystals are what you want for gem quality. See this little white and black thing that was right behind her head? That's where blood ran through this, whatever it was when it was alive. I'm telling you, everything was alive at one time. Okay, what you're seeing here is a lung that is in the microscope. And this is what it looks like on the fabric of the lung. These are two other lungs. This one here was DNA tested human, and it still has the same plur as the one I showed you in the microscope. This one is completely down to where it leaked all the blood out, except down in this area down here. You see all those little red spots? This is what came out of those red spots. The blood. Alright, now, and not every one of them had this big of a blob, but they all had red spots coming out when it first came out of the ground. Because when these are in the ground, they're literally inside of flesh. Mud, if it's wet and stays wet and it's clay type of mud, that is literally flesh that has come off of the body. It is. It's what it is. So it keeps the blood in here. And when I took it out, it leaked out. Now, these are the alveoli. Alveoli are the little tiny holes, which I showed you wherever that little line is. Here it is. These little tiny holes here. Well, you can't see. Well, I can turn the lights back on because we don't need a microscope anymore. We'll go back to the microscope in a minute. But these are the alveoli, same as here. Right? And the same as in the anatomical model here. Now, remember I said holes fill up with quartz? This just happened to be in a place where it wanted all the quartz it can get. And all the blood flushed out as much as it could get out. There was some left in the layer which faced right up against the mud, and the rest just filled in with quartz. That's what they'll do. They'll fill right in. Now, the reason you still have the whole thing just didn't turn into one chunk of quartz, because This particular type of tissue, this real collagen, has a fabric to it that just doesn't get invaded. Just like this stuff over here. That just didn't get invaded, and that is identical to what this is. Now, where do you see this? This is a lung. Now, I told you they're all flat, right? This is the one that's in the. You see how flat that is? It died like that. And this is where all the blood came out of. I took blood out of there and had it tested. And I mean, I did it very carefully, and it was very dense, and I showed how I did it. It's very simple. Now, this lung, where do you see this? The other side, half of the pleura is on, and half of the pleura is rubbed off. This is the red inside of the lung. This is the pleura. See, remember I showed you that side? See how flat it is? They all died in a flood. And it was, according to Velikovsky, it was a hot water flood, and the creatures literally boiled in the oceans, in the waters. And it was just an absolute disaster on Earth. And from what I can see, I don't think he was wrong. I think he was exactly right on target. Okay, I think I've shown enough to give you something to think about. Now, what are we going to do going forward? We're just going to have to keep examining these things and think about what was happening in our past. The things that were written, the things Velikovsky spoke about. I had a person just tell, oh, that guy was crazy, he's crazy. They still think that today. Everything he said, as far as I can determine, holds water. And he actually went and did the actual work of investigating all this stuff, not just to dismiss it. I have found so much dismissive science. It's absolutely, I'm stunned. I'm stunned. Today I'm still stunned. I thought education was all about learning, but it's about defense of what isn't right at this point. So we're going to find out what's right. Stick with me. We're going to go through this stuff. Somehow we're going to have to end up having a streaming live where I can say these things, and then you can say, oh no, Roger, that's not right. That's oh, you're lying. Like somebody's going to say, oh, you're saying that's gold. Oh, this is all happened by accident. No, somebody obviously squirted whatever this is, some kind of gold glue. You know, this is the kind of stuff you get from people that really just want to be dismissive. I want questions that are legitimate questions, and then we can answer them and say, why do I think that's a bone? Well, let's take a look at what bones look like. Let's take a look at what the anatomy of bones is and where the holes are in them and how they join together and ligaments and tendons and what the marrow looks like and what chemistry is here. And then look at it in the microscope. And these are the kind of things I want to discuss with people, not just have them dismiss it and say, oh, you did this, you don't know what you're talking about. Because just having back and forth on text, very, very draining. Because, you know, you say the same things over and over and over, and they say, oh, you keep saying the same things over and over. Yeah, because nobody listens. What do you want me to just stop going to woods? That's not going to happen. So I take that as a bit of an insult. We say, oh, you keep saying the same things, why don't you do something else? I do everything. But nobody just listens to, well, you know, there's a few. I'm not saying nobody. See, that's the other thing. Oh, listening. Well, there's a handful that are listening, and then there's the rest of the world that just never sees it because it's not really acceptable. Basically, that's what I'm seeing now. They can't accept it. Not that it isn't real. It's not that it isn't true. It's not that I can't back it up. It's not that I don't have DNA tests. Not that I don't have specimens. It's just it can't be accepted. And for me, that's not acceptable. How's that for a dichotomy?